Okay, the video is officially, guys, the video is officially running, okay? Video is running, great. All right, so we're moving into a whole new section, right? This is awesome. We're moving behind, everything we've done before is, we're leaving it behind. We're moving into exponents. My guess is everybody's been exposed to exponents to some degree, am I right?
Yes.
I would imagine that you guys know that 4 squared is what? Is this?
It's 16.
Is it 4 times 2 or
No.
is it 4 times 4?
It's 4 times 4.
Do you guys know the answer? How many people think it's 4 times 2? Raise your hand.
Wait, exponents?
Yeah.
4 times 2 is
4 times 4.
It's
4
times
4.
4 times 4.
8.
8.
4 times 4.
And that's 16.
4
Right.
times 4 is 8.
It is 16. That is right. This is 16. It's 4 times 4. Good. I just wanted to be sure. I just wanted to see how much you guys knew, whether you actually knew that. So we're going to first of all, let me just do this. If I have 4 to the 8th power, 4 to the 8th power.
That's 4 times 4 times 4 times 4 times 4 times 4 times 4.
So this, it's okay. The 4 is your base. That is your base, right? That's your base. Okay? So when I talk about a base, like multiplying same bases, the bases have to be the same thing, right? So when I say the base is 4, if I'm going to multiply that times another thing with the base 4, then I can do some cool stuff. But if they're not the same bases, I can't. Now this is called the power or the exponent, right? So most people would say this is 4 to the 8th power. Some people are singing. This is a lecture. I've got this on, right? Okay? Power or exponent. Most people would say this is 4 to the 8th power. That's how you would read that, right? 4 to the 8th power. Now, what we're going to be talking about today is actually multiplying same bases with exponents. But before we do that, let's just practice bases and exponents for a second. This means what? This means 4 times 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 4. Am I right? There's 8 4s, right? Right? That's what that means, right? So sometimes we're going to be dealing with number bases, and other times we're going to be dealing with variable bases, okay? And sometimes our bases will be weird, like a conglomeration or a mixture of both numbers and variables. For example, so what about this? What if I said 2x squared? What does that really mean? The squared is next to what? It's next to parentheses, right? When the squared is next to parentheses, it squares the entire thing. My whole base, my base is 2x. It's not just x. Does that make sense? So this would be 2x times 2x, right? Right? Now there's also, almost, but there's also a property called the commutative property. We're just getting all of this stuff out of the way right away. Commutative. Am I spelling that right? Commutative property. And that says multiplication. It says like basically if I've got x times y is equal to y times x. Like it's totally legal to move them around. Do you see what I'm saying? It doesn't matter which one I have first, which one I have second. So with a problem like this, I can do 2 times 2. I can put the two numbers together. Does that make sense? And then I can put the two variables together. Times x times x. All right? So when you see these parentheses, it just means you're going to be putting them however many times that says. That's how many times you're multiplying them times each other, right? Like, I'm going to explain all this later. I'm not going to show you the final answer yet because I want to talk about the actual rule, okay? But I just want to be sure we understand bases. Let's say I had
wouldn't it be like 4x
exponential.
Yes. So this would technically be 4, might as well do it, x to the second power, right? Because think about it, you guys know exponents, right? X to the second is what? It's the base times itself twice, right? So it's x times x. So if I have x times x, it's going to be x squared, right? So good. Awesome. Okay. So I think that's all I need to do for the intro. Now, let's actually do stuff. Let's say I said when we're actually multiplying same bases. So here's our first one. 5 squared times 5 to the 5th. 5 squared times 5 to the 5th. Let's just do it the long way first. Let's figure out what is 5 squared?
5 times 5, 25.
5 times 5. All right, that's the first one. Okay, the second one is 5 to the 5th. What would I do there? 5 times 5 times 5 times 5 times 5, right? Okay, that's the second one. All right, what does this equal? How many 5s are there?
21.
1, 2, 3, 4, 5, 6, 7. There are 5 to the 7th. That's what that would equal, 5 to the 7th. I keep the base.
78,125.
So look at this. When I am multiplying same bases, these are the same bases. I've got a 5 and a 5, right? As long as the bases are the same. You taking notes, dude? For sure? Okay, just want to be sure. As long as the bases are the same, then this works really easily. Notice we can count the number of bases, and that's what we put as the exponent. Does that make sense when you're multiplying? You see that? Now, can anybody see a shortcut? Raven.
From the beginning, you just add the powers.
Oh my gosh, look at that. That's amazing. What is 2 plus 5? Oh my gosh. So instead of doing the long way, we could have immediately just done this. We could have said it equals 5 to the 2 plus 5, which is equal to 5 to the 7. That's your shortcut. And so what we're going to be talking about, algebra, a lot of algebra is about shortcuts, okay? And so that you don't have to do this stuff you don't have to, that it would take forever. Some of the problems I would give you would take literally forever in order to solve them using the long form. So the shortcuts are what we're going to be focusing on during the next few weeks, right? Or next month maybe even. Because I don't know how many times I have you. So all right, so here's the rule. This is the rule. This is what you will see in a textbook when they say this rule for multiplying. A to the n times a to the m is equal to a to the n plus m. That's your rule. And it makes sense. They're just using variables because they wanted to refer to anything. A would be any number. That's your base. It's the same base here. One's raised to the n power, one's raised to the m power. We're multiplying same bases with exponents. We keep the base and we add the exponents. Make sense? You guys all see that? Make sense to you? All right, so let's do one. Let's do another one. How about this? What is 8 to the 4th times 8 to the 10th? What would it be?
8 to the 14.
8 to the 14th. Beautiful. See how easy that is? It's awesome.
Oh, is that just the answer?
That's the answer.
Wait, Gary. So you
Now, yes, you could give me an answer. You could go, well, let's see, what is 8 times 8? That's 64. Times 8 is times 8 times 8, right? But usually when they're big numbers like this, it's not worth trying. Just leave it like this. It's totally fine. If your answer had been, like if I'd given you this, 8 to the 1 times 8 to the 1, that's 8 to the 2, which is 64. If it's easy, go ahead and give me the final answer. But if it isn't, right? Because I just added these two ones to get a 2.
It's easy.
8 times 8 is 64. That's easy. This would be hard. 8 times 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 8. I don't even know how many I did, right? It's too much. too hard. Don't do
Is
it.
there an easy way to like type that into a calculator?
Yes, some calculators have a button that's, I think it's like this, x to the y. It wouldn't be on these calculators, but it would be on
Like phones.
that slightly fancier one. Some of you guys have a slightly
Wait,
fancier
can we
one.
use our phones?
Do you have one? Yeah, your phone will have it, I believe.
Wait, so do we have to put the actual answer or
I have
do
the
we just put
basic
18?
calculator. I have
You can put 8 to the 14. That's
Okay,
fine.
so can you put that
Yeah,
on the answer?
yeah.
Dude, that's
So,
Is that all the answers?
all right. So now let's start. Now let's do, guys. So let's do a couple with variables, right? Because most of algebra doing these is going to involve variables, okay? So here we go. How about I give you x to the 5th times x to the 6th. What would that be?
X to the 11.
Yeah, exactly. Same bases. They're the same bases. They're both x's, right? So I keep the base, right? And I add 5 plus 6, which is x to the 11th. You don't have to show this step, right? I'm showing you so you can see what I'm doing, but you can go straight to this if that's easiest for you. All right, so let's go over here. Let's have number 5. Let's say I did x times x times x times x times x.
It would be X to the 1, 2, 3, 5.
Do these have exponents?
No.
It would be x to the 5.
Everything actually has an exponent. It's not a
Wait,
zero.
Gary, I have a question.
It's not a zero. Wait a minute.
I
Let me.
can't see the.
Everything has an exponent, and if you don't see one here, right?
All of them have a 1 over.
It's x to the 1. So technically, when you have just a plain x, it's x to the 1 power, x to the 1 power, x to the 1 power, 1, 1. So therefore, Raymond was right. The answer is x to the 1 plus 1 plus 1 plus 1 plus 1, which is x to the 5.
I was so right.
All right? All right, let's try this one. What is x times x squared times x cubed?
It's x to the.
It's x to the triangle.
X is 7.
6.
6.
3 plus 2 plus 1.
6.
It's 6.
Right.
See, I'm smart.
All right, so here we go. How about this one? All right, how about x to the 4th times y to the 6th? So Caleb, focus on this one. Okay, yeah, go ahead, Gavin.
Wait, would it just be x? Wait, no. Would it
You're
just be
right.
the same thing? Just like x.
Yeah, so say it.
It's like you copy that.
Yeah, the answer is this, guys. It's x to the 4th times y to the 6th. Why?
Because you can't do anything until you know
Wait,
the
is that
algebra.
the answer?
What does the title say? Multiplying same bases. The bases are totally different, right? So I can't combine them. The only thing I can do is just rewrite it. Does that make sense? The bases are not the same. Do you see that, Caleb? Does that make sense? Right? All right, how about this? Now I'm going to throw in some numbers. What if I gave you 2x to the 6th times 3x to the 5th? Okay, remember, commutative property says I can move things around, right? When I'm multiplying.
And make it like 5x plus,
Multiply.
Oh, so 6.
5x to
2 times 3 is 6, right? Yeah.
11 power. 11
And
power.
then x to the 6 plus 5, which is 11. Beautiful. Nice job. Excellent. Right? All right, let me erase this side. All right, 8, 9. Where are we? Okay. What if I what if I did something tricky? What if I said this? 3x. Okay, guys, I'm going to give you a tricky one. 3x squared times 4x. Okay, here we go. 3, so Caleb, at this point, you guys really have to pay attention. We've only got 1 minute left. Okay, Gavin, what would you do?
What do you mean? Never mind.
12x. Would it be 12x? Third power. 12x to the third power.
Oh, wait a minute,
No,
wait a
there is
minute.
no power over the other one. It's
Wait, there's a power here and it's next to a parenthesis, which means the whole thing is a base.
9.
So I've got to do this. I've got to do 3x times 3x times 4x, right? So what is 3 times 3 is
So it's 36x.
times 4. Go ahead, Gavin. What did you say?
36x.
36 what?
X.
To the second power.
X. 36 puppies and X's.
X to the what?
Third power.
Second power.
Don't you know power? It's no power. No power. No power. It's power
Wait,
levels are
wait.
over 0.
Wait. So think about it. This is 3 times 3 times 4 times x times x times x.
There's no
Right?
power.
Well, wait. The power is a hidden 1. A 1.
Woo!
She said that.
So if
We're already dealing with
if
power.
an x doesn't have a Shh, guys, if an x does not have a power, it does have a
Well, then
power.
that's why you should add the powers in the first place. Because it's not, if it's the power at the very beginning, 3x to the second times 4x. Now the powers outside the parentheses, so maybe you should add them first. So it's like
What do
3.
you want?
So-
3x times
You can.
3x
Yeah.
to the fifth.
So
So
it'd be
what is the final answer? X to the
third.
right?
Yeah, it'd be x to the third.
36 x to the third is the answer,
See,
guys.
Erica, I was right.
Right? All right, one last one. One last one. Let's just be sure you guys have this. Let me just be sure I'm not forgetting something on this.
We have
Confuse
break
you
now.
guys.
Gary.
All right.
Can this be the last one, Gary?
Yeah, this is the last one. 4x squared times 2x to the fifth. Okay, here we go. How about that?
How about that?
I don't know.
So when it
Oh.
you could add the powers
It
because
would
there's
be
4 of
8x.
the little things, right? And then so it could be 4x.
It would be
So let's just do this. It's 4x times 4x, right?
8x.
Times
That'd be
2x to the fifth. So I'm going to do 4 times 4 is
10x to the fifth. So it'd be
16.
16x to the fifth.
16 times 2.
16x to the fifth.
Wait,
32x to the
32x to this.
32x to the seventh.
Oh, wait,
This-
I mean, yeah, 36.
Right?
Lisa's a genius, guys.
Good.
She said
Right?
they did.
She should go to the
4 times 4 is 16. Times 2 is 32. So that's 32. X to the 1 plus 1 plus 5, x to the 7.
Well, to the
All right, so that's it. So let me just turn this thing off.
Do you need this?
Kind of in a hurry here.